Archimedes, the approximation of pi. Jordan Sigai.
Born in 287 BCE, Archimedes was the son of an astronomer and mathematician named Phidias. Aside from that, very little is known about the early life of Archimedes or his family. Some maintain that he belonged to the nobility of Syracuse, and that his family was in some way related to that of Hero II, king of Syracuse. Archimedes traveled to Egypt in order to study in Alexandria. Founded by Alexander the Great in 331 BC, Alexandria had, by Archimedes' time, earned a reputation for great learning and scholarship. After his studies in Alexandria, Archimedes returned to Syracuse and pursued a life of thought and invention. Archimedes is known as the father of integral calculus and the father of mathematical physics. King Hero II had anticipated such an eventuality. Before his death in 216 BC, Hero set Archimedes to work, strengthening the walls of Syracuse and modifying its great stronghold, the Euryalus fortress. Archimedes also constructed war machines to defend Syracuse. When the Romans arrived under the command of the famed general Marcellus, Archimedes was prepared. Archimedes made such extensive preparations, both within the city and also to guard against an attack from the sea, that there would be no chance of the defenders being employed in meeting emergencies, but that every move of the enemy could be replied to instantly by a counter-move. Nevertheless, in 212 BCE, when a soldier demanded Archimedes accompany him to the quarters of Marcellus, he simply refused, and continued his ruminations. The enraged soldier flew upon Archimedes, striking the 75-year-old eccentric dead. Archimedes' tombstone was engraved with an image of a sphere within a cylinder, after one of his geometrical treatises.
He was so interested in solving problems that it more or less became his hobby. It was said that he would draw in dust, dirt, or whatever was available. He was also known for his drawing of geometric problems on his stomach with olive oil. His most well-known solution was in regards to the golden crown. King Hero was worried that who was making him a golden crown was replacing some of the gold with another metal. Calling upon Archimedes to find a way to see if the crown was made of pure gold or a combination of metals. Archimedes came upon the solution on how to prove this as he was taking a bath. Upon entering a full tub of water, he noticed that the weight of his body displaced a certain amount of water. Knowing that this same principle could be used on the crown, he forgot himself with excitement. He jumped out of the tub and ran naked through the town, yelling, "Eureka! Eureka! Give me a place to stand, and I can move the earth," Archimedes said. The king asked for proof. Archimedes attached a system of block and tackle to a fully laden vessel that had been drawn ashore by many men and proceeded to move the vessel along smoothly and safely from a great distance by merely pulling with one hand on the device. At this, Archimedes invented a device that enabled Hero to launch the ship on his own, called Archimedes' screw. Hero proclaimed, from that day forth Archimedes was to be believed in everything that he might say. One other device attributed to Archimedes in conjunction with the siege of Syracuse is a burning mirror that set the Roman ships on fire once they were within bowshot. Recently referred to as Archimedes' death ray, it is believed that such a device was made by Archimedes, although it was not used as a defensive weapon. While completing problems for the king, Archimedes made many advancements in mathematics and sciences. Archimedes invented the sciences of mechanics and hydrostatics, discovered the laws of levers and pulleys, invented one of the most fundamental concepts of physics, the center of gravity, discovered and mathematically proved the formulas for the volume and surface area of a sphere, showed how exponents could be used to write bigger numbers than had ever been thought of before, proved that to multiply numbers written as exponents, the exponents should be added together. Archimedes was intensely interested in calculating the mathematical properties of curved solids, such as cylinders, spheres and cones. To do this, he wanted to learn more about pi. We now know that is an irrational number. 3.1415926535897. The numbers after the decimal point never end, so an exact value can never be found. Archimedes knew that the circumference of a circle equals 2 pi r, where r is the circle's radius. He imagined a circle, and in his mind drew an equilateral triangle inside it, with each point of the triangle touching the circle. Outside the circle, he drew another equilateral triangle, with each side touching the circle. He could easily calculate the perimeter of each triangle, and therefore he knew the circle's circumference was greater than the inside triangle and smaller than the outside triangle. Then, using a formula he had devised to calculate the perimeter of a polygon with double the number of sides of the previous polygon, he repeated his calculation, this time for a circle with a regular hexagon inside it, and a regular hexagon outside it. The hexagons enclosed the circle more closely than the triangle's head, and their perimeters were nearer to the true circumference of the circle. In this way Archimedes tightened the limits for the maximum and minimum circumference of the circle. Next, he imagined a circle between two 12-sided regular polygons, then two 24-sided regular polygons, then two 48-sided regular polygons. Finally, Archimedes calculated the circumference of a 96-sided regular polygon inside his circle, and a 96-sided regular polygon outside his circle. A 96-sided regular polygon looks the same as a circle unless you zoom in with high magnification. Archimedes found that was greater than the fraction 25,334/8,069, and less than the fraction 29,376, 9,347. For the world at large, he simplified these numbers, losing a tiny amount of precision to say, was bigger than 3, 10, 71 and smaller than 3, 1, 7. If we average Archimedes' best upper and lower limits for, we get it to be 3.141868115 to 9 decimal places. Archimedes' value of differs from the value on your calculator by less than 1 part in 10,000. Look how closely a 96-sided polygon resembles a circle. You can hardly tell the difference. Within the next 2 slides, look over the proof of Archimedes work for calculating pi. The work easily followed, but used lots of assumption for the statements. The statements do follow through with correct units within the diagrams. The Babylonians, c. 2000 BCE, used 3.125 to approximate pi, a value they obtained by calculating the perimeter of a hexagon inscribed within a circle and assuming that the ratio of the hexagon's perimeter to the circle's circumference was 24/25. The Rhind Papyrus, c. 1650 BCE, indicates that ancient Egyptians used a value of 256/81, or about 3.16045. Ancient Egyptians calculated the area of a circle by the following formula, where d is the diameter of the circle. Formula 8d/9 squared. This yields an approximate value of 3.1605 for pi. Fibonacci never obviously wrote the previous result, but his series and its derivatives are in the heart of this formula, and he began a calculation of the decimal of pi. After Descartes' death, the method of isoperimeters will be found in his papers. It consists in making the opposite of Archimedes' method. It should tell to determine the radius of a circle of which the perimeter is fixed in advance. European mathematicians in the early modern period developed new arithmetical formulae to approximate the value of pi, such as that of James Gregory, 1638 to 1675, which was taken up by Leibniz. Pi/4 equals 1, 1/3 plus 1/5, 1/7 plus dot 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 dot. One problem with using this formula to calculate the value of pi is that you would have to add 5 million terms to work out a value of pi/4 that extends to 6 or 7 decimal places. In 1706, another mathematician named John Machin developed a refinement on Gregory's formula, yielding the formula still used today by computer programmers to compute pi. Machin's formula, pi divided by 4 equals 4r dane, 1/5 r dane, 1/239th. Using this formula, an Englishman named William Shanks calculated pi to 707 places, a labor of many years, which he published in 1873. Only 527 places were correct, however. The symbol for pi was introduced by the British mathematician William Jones in 1706. This symbol was adopted by Euler in 1737 and became the standard symbol for pi.